Hello everyone, so my name is Nejc Bezak. I come from the University of Milan, Faculty of Civil and Geodetic Engineering, and today I will talk about the climate change impact evaluation on the water balance of the Koroška area located in Slovenia. So the activities conducted here were also done in the scope of our UNESCO chair on water-related disaster risk reduction that is held by the University of Ljubljana. And of course, all the activities were done in the scope of the applied projects funded by the Slovenian ministry. So climate change is expected to affect the water cycle components such as rainfall, surface runoff, subsurface fluxes, and their relationships. However, it's not clear how will the temperature increase impact on the rainfall runoff dynamics, which is also related to the landslides and debris flow triggering mechanisms. So in Slovenia, that is a country characterized by steep slopes and tectonically landslide susceptible areas. So one of the endangered areas in Slovenia is also the Koroška village. It is located in the northwest part of Slovenia. So it is located below the Potoška planina, slowly seated landslide with a sliding mass composed of tectonically deformed and weathered upper Carboniferous and Permian clastic rocks covered with a large amount of talus material. So Slovenia is located, is a relatively small country with about 20,000 square kilometers, located between Austria, Italy, Hungary, and Croatia. So in the last 2 to 3 years, detailed fieldwork, lab experiments, modeling, and conceptual design of hydrotechnical measures to reduce the risk was conducted at this location. And you can also find more information in our recently published paper in the Landslide Journal. So where we show some of this fieldwork that was done, like experiments and especially conceptual design of the hydrotechnical measures to reduce the risk. So in the area of the Koroška that is located in the northwest part of Slovenia, here near the border with Austria. So this is the Bela stream. So the Koroška village is located here. So there are basically 4 major landslides. So the Chikla landslide, Urbis landslide, Potoška planina landslide, Odešnik and Mandeš landslide. So the main aim of this specific contribution was to evaluate the climate change impact on the water cycle in the Koroška area. So in the upstream part of the Bila stream, there's, as you were able to see, at least 5 potential bigger landslides are located. So we were interested in impact on the rainfall, evapotranspiration, air temperature, surface and subsurface runoff, using the conceptual hydrological model. So we used a lumped conceptual hydrological model named GR4J, and also the enhanced version GR6J with included snow model. It is named Nejc for this task. So the basic structure of the model with the 4 parameters, you can see it here. So it's basically a conceptual model with 2 underground stores, so the production store and the routing store, and some unit hydrograph theories used to derive the total runoff from the area. So a bit different representation of the characteristics of the 4 parameters that are used in the 4 parameter version of the model. And the snow model basically also uses catchment hypsometric curve to account for the snow accumulation and snow melting due to the catchment. So for the rainfall data, we basically use the Javorniški road station, which is located only 3 or 4 kilometers from the catchment boundary. So this black border here is the Bela stream catchment boundary. For the air temperature data, we use the Planina Golico station, which is around 5 to 7 kilometers from the catchment boundary. And since the Bela stream catchment is completely engaged, we use the discharge data from Slovensky, from the nearby, from the adjacent nearby Slovensky Javorník catchment or river or stream, since the characteristics of both catchment areas are quite similar in terms of slope, major land use, and of course annual precipitation is almost the same. So a ratio between the catchment areas is used to translate the discharge data from the Slovensky Javorník catchment to the Bela stream. So we used 5 different combinations of global climate models and regional climate models, so GCMs and RCMs. So here, basically, these 5 models are listed. So model 1, let's say that we are maybe then model 1, model 2, model 3, model 5, and model 4. We only use the RCP 4.5 scenario, which can be regarded as a midway scenario between the other two, that are less and more extreme. So the data was prepared by the Slovenian Environment Agency and is now available at 1 kilometer resolution. So we basically as well as corrected and downscaled data. So more information about how this was done, you can find it in our conference proceeding paper. So firstly, we calibrated the model. So the calibration results are shown here. So in the upper panel, precipitation. So this is the air temperature. As you can see, the calibration was performed for the period from 2013 till end of the year 2017. Here is also the snowpack in 5 different elevation layers that were modeled within the selected hydrological model. So the GR4J, that included snow model. So included same Nejc snow model. Here is comparison between the simulated and observed flow, and also 30 days rolling mean, non-incidence probability, flow duration curve, and a scatter curve between the simulated and observed flow. So the Nash-Sutcliffe coefficient that is often used to evaluate the performance of such models was 0.75, where a value of 1 would indicate a perfect fit between measured and model data, and the range of this coefficient is between -infinity and 1. So basically, we evaluated climate change impact on different variables. So we did compare 3 40 years period. So as a reference scenario, as a reference period, we used 1981 to 2020 period, and we did a comparison with 2021 and 2006 to 2060 period, and also for period 2061 and until the end of the century. So please note some differences in the units used. So basically, we used relative difference between the 2 periods. So we compare the 2 future periods with 1 past reference period. Only in case of air temperature, we use the temperature anomaly. So as you can see, so this is the impact on the total rainfall. The climate models for the RCP 4.5 scenario do predict some increase in the mean rainfall. The same applies for the air temperature, where this increase in terms of temperature anomaly is quite significant. Also, in case of average transpiration, there is in general some increase up to around 5% generally. The same for the effective rainfall. So the effective rainfall means basically net rainfall, so total rainfall minus rainfall losses. So this means like rainfall interception and stuff like that. Also, in terms of runoff, total runoff from the Bela stream catchment, there is some increase predicted in by the selected 5 climate models. And the same applies for the production store level. So the production store level is basically the conceptual underground reservoir. So, but in this case, the increase is only slightly above 0 for the second scenario to the end of the century, and is in general as average below 0 for the first future scenario. So this is basically the production store level. So it was found in this paper that this production store level, so the amount of water in this production store level, can be used as a rough proxy of the wetness condition in the catchment. So it should indicate if the wetness conditions in the future will be more like unfavorable of landslide triggering. So these are also the results of the percolation from the production store level. So this is basically this outflow from the production store level. So as you can see, or you were able to see, there are quite some differences between the 5 selected models. So some do predict like negative, so a decrease, and some increase of different variables. So the most consistent results are basically obtained for the air temperature values, where all 5 models predict an increase, while in case of other variables, there are some models. In case of most of the other variables, except for also for the perspiration, it is directly related to the air temperature. Some models do predict also a decrease in the let's say water cycle components. We also evaluated climate change impact on the intensity duration frequency curves, where again bias corrected and downscaled point data was used for this purpose. So this was like additionally done. The analysis was done for different rainfall directions and for different return periods. So here you can see some results. As you can see, there is only slight increase predicted by the 2 future periods compared to the reference periods for the EDF curves are for 2 and 4%. So let us conclude. So total and effective rainfall, air temperature, precipitation, and runoff from the Bilastream catchment might increase in the future. For most of the variables, the average differences calculated using 5 different models were in the range of the 5% of the relative difference, with the exception of the air temperature, where temperature anomalies were in the range of 1 to 2 degrees. So the production store level that can be understood as a proxy of the catchment wetness conditions related to the possible triggering of the landslides, and also consequently the brief flows is projected to be more or less the same as in the past. So relative differences, average ones are less than 1%. So this could indicate that landslide activity in the future could be similar to the situation of the past. So the same results were obtained, or similar results were obtained also for IDF curves, so for the intensity duration frequency curves. So it should be noted that there were relatively large differences among the 5 tested models, as I already mentioned, and we only used the RCP 4.5 scenario and not also 2.6 and 8.5 scenarios that can be regarded as optimistic or pessimistic scenarios. So, but anyway, this 4.5 can be regarded as a midway scenario. Please also see other publications related to the Korosh-Kadela landslides, and especially the one that was recently published. And thank you for your attention. And in case of any questions, I will be glad to answer. So you can also contact me via email, ResearchGate, or any other mode.